Hello, everyone, and welcome back to Identity Insights by Indicio. I'm your host, Tim Spring, and today I'm joined by Indicio's senior software engineer, Colton Wolkins, and he's here to discuss a new interaction between DIDComm and the Internet of Things, or IoT devices. Thanks so much for taking the time to join me today, Colton. Would you mind giving us a brief introduction about yourself?
Yeah, certainly. So I am a senior software engineer at Indicio, and I work primarily on the open source foundational stack here. And I am also the co-chair, or a co-chair of the DIDComm users group.
So for those unfamiliar, could you tell us a little bit about what we mean when we say DIDComm?
So DIDComm is a meta protocol. So similar to HTTP, TCP, there are these different protocols that make the internet work. And a lot of applications are built on top of them. However, both TCP and HTTP, which is built on top of TCP, all of these messages are they're very extensible to build on top of. However, they're all unencrypted. And in order to make the messages encrypted, you have to wrap the messages in SSL. You have to worry about SSL certificates and all sorts of like the keys and everything. But with DIDComm, all of that is provided to you out of the box. You still get all the flexibility of HTTP and all these APIs, but you're getting the added benefit of every single message from point to point is encrypted. So no matter how many hops between the source and the destination there are, you can know with assurance that every single step of the way the message is encrypted, and nobody in between the source and the destination can see what the message is except for who the intended recipient is.
All right, that sounds very useful for sure. And again, for those unfamiliar, could you tell us a little bit about what we mean when we say the Internet of Things? What does that refer to?
Internet of Things in general refers to devices like, smart home devices, whether it's your washing machine, your doorbell, your door lock. It refers to all these different devices which happen to be connected to the internet. They're not a full-blown computer, though some of them can have a built-in computer. They're not like your personal computer, and they are devices that are connected to the internet with the intent of providing some form of service, such as a light bulb that you can, on your smartphone, change what color the bulb is or turn it on or off remotely.
All right. Obviously, I've I've seen those around, and that's a good comparison, the light bulb that you can control from your phone. So what does DIDComm bring to, being able to interact with those Internet of Things devices?
One of the huge things about DIDComm and Internet of Things, in my opinion, is first off, interoperability. And that is when you have all these devices, they're all made by different manufacturers. They're all speaking their own sort of customized lingo that only they know. And if you want your smart light bulbs to turn on when, the dishwasher is done, right? Some they turn red saying, "Hey, the dishwasher is done" or something. There's nothing really e there's nothing readily available to just make that work. And if you wanted to build your own device, you have to learn what's going on both through both like the dishwasher and the light bulbs and figure out how to tie them together. So one of the huge things in my opinion, or rather not opinion, but one of the huge benefits that it brings is that all of these devices can talk, they have the ability to talk to each other now in a way that you don't have to pull up like the Rosetta Stone and figure out, okay, what does this device say? What does that one say? And how can I get them to talk to each other? But another huge thing, is that, as I mentioned earlier, DIDComm provides the benefit of point-to-point encryption. So when you connect it to your smartphone, the messages from the light bulb or the dishwasher go into your smartphone, you know that those messages can only be seen by those holding the smartphone, not by any sort of corporate middleman behind the scenes brokering the data. No one else can control the device except for you.
All right. Obviously, that sounds like a huge step up in terms of making sure your devices aren't listening to whatever you're doing and collecting data on you. I understand you recently showed off a proof of concept at the recent IAW through a Raspberry Pi device. Would you be able to tell us a little bit more about that?
Absolutely. This was one of the big things that I brought to IIW this year in relation to DIDComm. So in my hands, I have this small little Raspberry Pi device. You can see just how tiny this is. I've got a battery pack here to provide power. So even without the battery pack, that right there is pretty small. It's got a multicolor e-ink display right here, and it's connected to the Wi-Fi. So this would be classified as an Internet of Things device. When this thing starts up, it automatically is ready to communicate with DIDComm. And if I share my screen here real quick. So right here, I have the development build of the DIDComm demo, which is available at demo.didcomm.org. And if I add a new contact, I've got the did peer address of the Raspberry Pi already in my clipboard. And if I paste that in, we'll notice that messages start getting sent. And then in a few seconds right here, it says Colton's Raspberry Pi 0. That is the Raspberry Pi communicating back saying, hey, this is my name. If I open this up, we see the messages going back and forth, but I have this custom protocol here for a name tag and the ability to set the name. So what I'll go ahead and do is for this set name protocol here that I've got, I'm going to set the name to Identity Insights. And what you'll notice is when I hit send, so I've got the Raspberry Pi right here. When I hit send, we'll see that the message was sent, and we've got a new status here saying pending, setting the name tag to Identity Insights. And in a few seconds, because it takes a few seconds for the script to run on the Raspberry Pi, you notice that the screen is now changing, it's blinking black and white. But over the course of the few seconds, it says changing on my screen. This name tag here, let me stop sharing so that the camera's a bit bigger. You'll notice that it now says,
Oh, wow.
hello, my name is Identity Insights. This is not connected via any cables. This is all wireless. And when I was giving the demo at IIW, this was actually connected to my phone's hotspot. So this was over the mobile carrier's data. And my laptop was connected to the conference Wi-Fi, and it was still able to communicate and change the name tag in real time.
Awesome. So that was pretty quick and definitely shows some cool functionality there. So I'm curious, right? Obviously, the technology looks to be in pretty early stages. What would you say is kind of possible now through DIDComm for IoT devices?
Really, what is possible is whatever people start implementing. A lot of devices right now do not communicate with DIDComm. They're communicating using their own special protocols. Some of these devices have like huge security vulnerabilities and what have you. As they start moving over to DIDComm, I only showed updating a e-ink, multicolor e-ink display here. But because it's a Raspberry Pi, one of these, low cost, low power devices here, it has a bunch of these header pins right here. And you can plug in a ton of different things into here. Things like temperature sensors, water sensors, figure out how, if your plant in the kitchen needs to be watered today or not. It can be hooked up to keypads, NFC, like all sorts of stuff that can be hooked up, any sort of like smart device. that you see, or even like the badge readers in the office, right? Those kinds of things can all be hooked up to a device like this Raspberry Pi here, a low cost computer, and they can start with the appropriate scripts written. They can start communicating DIDComm. They can start sending these encrypted messages point to point. They could start interoperating with other devices, such as, the badge reader. It reads the card and then opens the door. If both the door and the card reader are both speaking DIDComm, they could be able to see all those messages and communicate without going through some third party system that may or may not work and interoperate.
All right, awesome. So yeah, it sounds like it's ready today then. It's just a question of if you've added the functionality to your systems then. Is that right?
Absolutely. Like the code is ready, it's available. All of the stuff that I showed off here is available on GitHub. It's all open source. And so really it's just need to get people implementing with it.
Awesome. Well, that's definitely good to know. And I think a great showcase of what this technology could do for, just your average person to your giant enterprise, because everyone needs their technology to talk to each other. I really appreciate you taking the time to speak to us today, Colton. It looks like that does bring us to the end of our conversation. If you at home would be interested in learning a bit more about decentralized identity technology, please be sure to subscribe to the channel. We'll continue to bring you some more educational content. And if you'd like for us to cover specific topics, please go ahead and leave us a comment below, and we'll be sure to read and address them. Thank you again to you, Colton. I know that you'll be speaking at the Identity Meetup from Indicio next week. Would you like to tell us a little bit more about that and where people can learn more?
Yeah, certainly. So some of the things that you can expect from the upcoming Indicio meetup are I'll show you how to get started developing cool applications like this. Um, and there will be other explanations from other people who are talking about, helping you to get started building today, since that's where we're at.
Awesome. I'll be sure